just like we did yesterday, we're going to start today's class with factoring out a GCF and doing the review. And I didn't write it in the instructions, but let's go ahead and add it now. Let's classify based on degree and number of terms, because it's always good to practice that when we get a chance. So go ahead and pause, try the 3 problems, and then when you're ready, push play to compare your work to mine. Before I show you all my work, I'm actually going to show you the mistake that I started making because I want you to see that we can catch our mistakes even when we make them. So when I started doing the first problem, I said, okay, 36, 54, well, those are both divisible by 9. And I identified the f and the g squared also as being part of the greatest common factor. But then when I went to find out what they had left, I saw that I had a 4 and a 6fg squared, and I went, wait, 4 and 6, those are both even numbers. I must not have gotten the greatest common factor. I just got a common factor. So I then realized I needed to go back, and I needed to say, well, if there was an extra 2 in here, 2 times 9 is 18. 18 must have been the greatest common factor, and I double checked, and sure enough, 54 divided by 18 is 3. So always be on the lookout, especially with sort of unusual factors like 18 going into 54. It's really easy to miss that on the first time around. I'm going to pause for just a minute to finish the rest of these problems, and then when it starts playing again, you'll be able to see the answers to all of them. All right, take a moment, check your work against my work. So just push pause so you can see the screen for a bit, and then go ahead and push play when you're ready to look at factoring by splitting the middle term. Okay, the 2 problems on the left are going to be the ones that I ask you to practice independently tonight for your daily practice. I'm going to do the 2 problems on the right with you here in class today. 2x squared plus 9x minus 5. I take a look at that. 5 is prime, so there's no GCF of all 3 terms, and we go straight to solving the puzzle. So I need 2 numbers that multiply to make negative 10 and that add to make 9. So I think it's going to be a 10 and a 1. I want it to come out positive, so it's the 1 that will take the negative. So I'm going to split the middle term into 2x squared plus 10x minus 1x minus 5. And then we're going to create the sum of 2 binomials. So I group the first 2 and the last 2. And I make sure to put in the positive sign because of the negative going with the 1x. Then I'm going to look for my GCFs. So with 2x squared and 10x, I've got a 2x in common. The top needs an extra x, and the bottom needs a 5. So we'll factor out that 2x, and that will leave behind the binomial of x plus 5. Next, we have negative 1x and negative 5. Those just have a negative 1 in common. And the top needs to multiply by an x, and the bottom by a positive 5. So we'll factor out the GCF of 1 and leave in parentheses the x plus 5. They have the binomial factor of x plus 5 in common, and that leaves behind a binomial of 2x minus 1. Now let's look at the last problem on the page. Right away you should notice something. I'll give you a sec to think. All right, I hope you realized that they have a negative 3 as their GCF. And I bet in your brain right now you're saying, but wait, Mrs. Leonard, they don't all have a negative. That's absolutely true. But anytime the first term in a set of terms has a negative sign, we pull a negative out of everything, because every positive number can be divided by a negative number and still come out evenly. So we're going to divide each of those terms by negative 3, which will leave x squared minus x minus 2 inside the big brackets. And then we're ready to solve the puzzle. So I want to know what numbers multiply to make negative 2 and add to make negative 1. Well, there aren't a lot of things that multiply to make negative 2, so we don't have a lot of choices. How about negative 2 and positive 1 to solve the puzzle? So we keep the negative 3 outside the big bracket, and we split the middle term. So we're going to have x squared minus 2x plus 1x minus 2. And then we're going to group it so that we have the sum of two binomials. And we'll look for GCFs within each of those two binomials. So these first two have an x in common and need an x and a negative 2 to get back to their original forms. So I have the negative 3 outside the brackets, and inside I'm factoring out an x and leaving an x minus 2 in the binomial. Then I look at the next two terms of 1x and negative 2. At first glance, you'd be like, no, Mrs. Leonard, they don't have anything in common. True. Well, they have one thing in common, which is 1. So they don't have anything other than 1 in common. So remember when you have that instinct, no, they have nothing in common. It's a 1. They always have at least that in common. So we're going to factor out a 1, and in parentheses, we're going to leave x minus 2. So I can see that I'm at the end. I've got a factor of negative 3. I've got the common binomial factor of x minus 2, and then the remaining binomial factor of x plus 1. All right, you have two problems that I left for you to do independently. We've been factoring for quite a few days now, so I hope you can do those two on your own. Give it your best shot, and then upload your work into the Google Classroom when you're done.